We are, things are moving along here, and I hope you are enjoying yourselves. Please be sure to give us feedback at info@bsidesto.ca so we know how we're doing. Both positive and negatives are good because otherwise we can't grow. All right, the next talk is called Cyber Zoology: Protecting Your Network from New Breeds of Attacks with a Raspberry Pi. Would you please put your hands together and welcome to the stage Patrick Kelley.
Good afternoon. Can everyone hear me okay? Too loud, too quiet? Be quiet. Go home, go back to America? Gotcha. Okay, so really excited to be up here, really excited to be in Toronto. Came to Sector a couple of years ago, drifted around this area. I'll be honest with you, 2 years ago, it would never have even crossed my mind that I'd have the opportunity to speak to any of you today. And to say that I'm humbled would really be understating it. So we're going to talk about some things that I've been looking into the last couple of years. And we're going to scope this down to Raspberry Pi so that you can take this home or take it to your lab or wherever you can to try some of these concepts out. I will be releasing all of the code that you'll see in here, the detections, on a GitHub repo. You can grab it. Also, the production image for the Pi 3 that I use for the things I'm going to show on these slides will be available as well. So you can image it and just do whatever you want to do with it. So, all right, so who am I? To be honest with you, I kind of get bored of myself. So in short, I'll skip to the most important part. Last night I got to see the first Leafs game. Go Leafs, go. Really exciting time. Again, if you're going to kick off in Toronto on something you never dreamed you were going to get to do, starting out with the Leafs game winning is a pretty great way to go. So let's rock and roll, okay? Why are we here? Logs lie. If you've ever set up a SIM, if you've ever done IR, if you've ever reached into a Windows machine, Linux box, if you've ever told syslog, after an incident, you'll understand that logs lie. Even if they don't lie, you're stuck to the technology and the fidelity of when that logging concept and that mechanism was created. In fairness, it's a good effort, but it's never going to be good enough. So, intrusion and detections on the border only tell a portion of the story, and this is something that I learned working 4 years with SourceFire and with Cisco and Dell SecureWorks. We would be able to pull some of the traffic down, and we would be able to see north to south, but we really didn't have any context around that. What did it mean? What did it do when it got through, passing through that thing? Bless you. But we can't go around dropping $20,000 SourceFire sensors everywhere we want them to go. It's just too expensive. And even setting up 1U, super micros may be outside the budget of your organization. So the problem that we're having is that the visibility was not multidimensional, it wasn't contextual, and without the qualification of threats, too much time was spent chasing things around. Has anyone in a room ever walked into work and had 7,000 indicators come out of your SIM or IDS and you find out that only 7 of them meant anything? It's a long day, right? Probably didn't get through those. So here's what I wanted to solve. First, what is this? Traditional is north to south, you're signature-based. They look for isolated atomic indicators. There's very little correlation that takes place. For instance, if it's Tor traffic, you may not care if that's coming off your guest Wi-Fi network. You would really care if you're doing IRC private messaging between your two VM or ESXi servers. That would be something that would probably perk your ears. Unfortunately, this past year we worked with a client, gave them packets of that happening, and they shrugged it. Welcome to my world. So what we're trying to do here is correlating those atomic indicators with full Bro-IDS proto-analyzation so that you have a better idea of what that attack traffic looks like and what's really going on. Then you can do some enrichment on those logs from disparate sources. That way you can add a little more color and context to it. So again, kind of beating this to death because even when I look at machine learning, even when I look at AI concepts, we're still leaning back on those old principles that we have already determined are broken, such as machine learning off of a signature, artificial intelligence off of a signature. We keep looking for that one atomic indicator, hoping that we get to see it again. And chances are you're probably not going to. So another problem that I wanted to solve, right, is when you're working in industrial control environments and things that have been engineered to have a shelf life of 20 or 30 years, even if you want to log things, you can't. There isn't a space to do it. If you wanted to backhaul logs, there isn't a mechanism there to do it with. You've got some significant issues here just getting the data to a place where you can figure out what's going on. So in my idea, after working with SourceFire through the conversion to Cisco when they are acquired, working with SecureWorks, working internally, these are some things that I look for when I'm making an effective security platform. Blended IDS. It's not good enough to have Suricata and then another signature base. We have to have the ability to drive deep down into packets, down into protocol flows, and bring that stuff out. The other part that I'm finding out is, okay, you find something, now what do you do with it? Most environments isolate you and silo you to their environment. That's not an environment that you're spending the rest of your time in. So you're having to make a concerted effort to go back and forth. This is why I really like being an import and export and sticks models. Is anyone here familiar with sticks? Thank God, I thought I'd be the only one. Okay, so short version of it, just so we can move along, is that the idea behind sticks is when you would export your indicators of a compromise, you would have a little more fidelity and construct and context around it, so you have better understanding what was going on at the time that took place. Again, I talked about logging. I beat on that pretty hard when I said, you know, even your logs are going to lie to you. But the fact is JSON's going to be better than syslog. I know that there are other things that are coming out that are a little less overhead, but JSON works. As I'm going to show here in a minute, that you've got to have some portability, because everywhere you go is not always going to have a nice 42U rack in there for you to shine, you know, push your shiny blinky light box into, right? So APIs to pull things back, extended connectability, pardon me, to Windows logs, passive total, virus total. So I started working on trains. It was called in by DHS. It's called with some vendors. There are some that are up here. And I said, we have a problem. We're doing positive train control, but we're finding problems. We have trains. We're putting Wi-Fi into them, but we don't really know how to get our heads around it. We think that there's something that happened on our train network, but we don't really know because we don't have any logs. Because we wanted to do logging, but there's no space in the ACC or the Recs to actually do that. What are we going to do? I said, well, great. I tell you what, I'll build an appliance. We'll come out. We'll rack it. We'll take the data back out of it. We'll take a look at it. I said, sorry. When we engineered this 30 years ago, there's no special slots. There's nothing open for you to use. By the way, you're probably going to have a problem getting power for what you want to do as well. Awesome. So I started looking at these things differently, right? You have OT and you have IT. IT is a little bit easier. You know, we can drop sensors in between VLANs. We can profile those sensors. If you're going to put it in a VM and the thing that you're wanting to look at is vMotion traffic, then we don't really need to load up protocol detection and deep packet inspection for everything else. You can lower that profile and that usage down. Additionally, what if the places that you need to backhaul traffic from don't have a dedicated 100 meg drop or a gigabit drop? What if they don't even have a cable coming into it at all? We have another problem. So the things to consider when you're going through this is consider remote sites. Consider executives' personal networks. I know that they hate to violate privacy, but if anyone's done IR, they understand that insider threats in layer 8 is the worst. So here we go. Let's move into in whatever you can make fit on a train. This is a real world jam right here. You don't always have rack space. They wanted to understand what was going on inside their traffic. Wireshark isn't going to do. I can't stick a laptop or a Dell-powered server in this environment. You have to think and do something different. So great, let's build a Raspberry Pi. I can power it off batteries, I can do something with it, and then I can do a proprietary, which are really hard to find and make, cable to plug to the J5 so we can get all that monitor traffic off. But here's this other problem. Security is a narrative, right? It's based on a fixed construct of time. If you don't have time and you don't have context, then you can't really determine exactly when things happen in the order and if you should care or you shouldn't care. But when you're dealing with trains, we're either doing Wi-Fi between wayside boxes, and if you're driving down the highway and you see the big metal boxes by the road, those are waysides. They connect back to the back office for the carrier. Or if you don't have that, we can do cellular. Cellular is very expensive. And then we move to the third option, which is just horrible for us to try and solve security problems, which is 220 megahertz radio. So imagine if you need positive train control to work, and the back office must have enough bandwidth to say you're running into a flood zone, and they can't get that across because we're blasting the wire with JSON full fidelity Bro packet logs. We didn't reduce the threat surface, we just increased the threat surface. And this is a serious thing. I like my French fries, I like my orange juice, and unfortunately we carry nuclear waste on trains too. So we have to think of how do we do back pressure and properly store and forward messages to the point that even when they come out of an area and we can get these logs, that do we get the fidelity that we need to make good decisions. So this is hard to do, but if you can, and you can get the logs coming into a Raspberry Pi using Bro and Suricata, here's a lat long. The next flow, I try to keep big words because I know these can be hard to read. But the next one is introducing the grade. Is the train going up? Is it going down? What is the speed that it's moving in? We can plot this across time. And as we do this, we look at how to determine a behavioral model around this. So did the train normally go 52 miles an hour up this grade or down this grade? Is there a problem in the cabin that caused there to be a change? Did we lose consciousness of the engineer? Can PTC take control? So you start getting some very interesting data when you start tearing down a protocol. It's stuff you're not going to get out of Suricata, and you can't run a laptop with Wireshark in these environments all the time. But it gets really interesting. Here's the break interface. Here's a warning. So we talked about new breeds, but let's talk about old ones before we get to the new ones. When you're dealing with trains, when you're dealing with airplanes, when you're dealing with cars, still, with CAN bus, most of that traffic is still using protocols that were cutting edge 25 years ago. They're subject to replay attacks. They're subject to you just telnetting in using wabtec or admin. An unfortunate thing is that most trains can be driven with a lockpick kit and admin. And if you can't use that, just alter the GPS that's being fed to the PTC on the train, and it'll be glad to do what you want that way, in case you just don't want to pick locks. So here's where I started solving this problem with Bro that you can't really get out of other IDS solutions. DMP3, you're going to be concerned with reset commands that they're coming from places that shouldn't be sending reset commands. If I jump onto a network and I want to alter an environment, or I want to stop a job, or I want to make a change, I can drop in, pull that traffic in plain text, because DMP3 and Modbus both are, and then do replay attacks, or do resets, or do any number of things. So one thing we can do with Bro, and I'm sorry if this is a little hard to read, but go ahead and define what you want to look for in there that would be suspicious to you, such as a function code reset. I'm really sorry about this. I really am. I tried to get the leanest Bro script I could find so that you could see it in this room and it make sense and not be trivial. But new attacks, and what I started finding when dealing with Suricata and other things, is that we are looking for a file hash, or looking for one piece of code that was in a Wireshark in a packet, or we were looking for some single atomic indicator. The problem is we're having to write signatures for every single thing that gets released that does the same thing. 29,000 some odd individual rules in Suricata is heavy. It's heavy in Snort too. I'm going to try to point this out if I can, but the idea behind doing this with Bro is that if you're using Empire, if I'm using Metasploit, if I'm using any number of things I use when I red team to get control of local admin and escalate up, I'm going to want to get the hashes off the domain controller. Now, pulling NCC or NC changes between two domain controllers is not a big deal. That's normal behavior. It's called replication. It's been a new hotness since 1999, right before it came out. But if you're a workstation that's not a DC and you're not in that list that's defined above as 192.168.02, then you're going to want to know about this. This may not fire Suricata. In fact, it probably won't. This is normal behavior. There's nothing for it to tell you that there's wrong with. You're using PowerShell. PowerShell is generally allowed in every environment on every workstation. So having the ability to contextualize what that DRS, NC change, and that replication looks like to someone that isn't a domain controller is going to be valuable. I didn't find an easy way to do this in Suricata. I found a very easy way to do this with Bro. No, this is just looking for one indicator to contextualize this. The only thing that's making a difference in here is that we've got a domain controller defined. But we could do this differently. Like you can sumstat this. So I'm not really worried about doing one time. I'm worried about doing 9 times. Or let's say we're looking for brute forcing, and I'm not so much worried about the 9 ones that failed because I'm used to my networking getting scanned. I'm used to the 9 ones failing and the 10th one succeeding. So that's something you can write in Bro scripting and you can run on a Raspberry Pi so that regardless of what that malware signature is, regardless of where it's coming from, it doesn't matter if I'm using Mimikatz, Kiwi, Empire, Bro, on and on and on, you're still going to see that behavior and you're still going to be able to fire on it. So now's the problem. How to ingest, properly transport data. I've seen a lot of people in networks push things over syslog and just send it to an rsyslog host. Please stop doing this. I know it's easy. The problem with that, though, is I can see all the traffic, and an attacker can see all of your traffic too. Additionally, and this is kind of an aside, but if you load a new device in and you move it from HTTP to HTTPS to make it more secure, and you turn off Telnet and you go to SSH, make sure you turn off SNMP while you're at it. Most of your vendors won't tell you that they left version 1 with the default private or public community strings. That's kind of a bonus round. Sorry, I did this pen test last week, and I was like, oh man, SSH and HTTPS, and man, this company's really doing the right thing. Oh, SNMP version 1. Damn. So you can do Splunk with signed certificates. That's super easy to do. You can use Logstash to bring the data back out if you want. You can do SSL curl direct to Elasticsearch from Bro, which is a lot of fun. And you can use Kafka. Now, I was speaking to somebody at lunch today, and they kind of lifted an eyebrow. I said, I'm using Kafka on a Raspberry Pi. I know this seems maybe strange to somebody who uses Kafka every day. But the problem that I had with Beats, Splunk, and Elastic, and Logstash was that they're heavy. They're really heavy. And if you start burning up the processor backhauling logs, then you're going to reduce your ability to capture traffic and log that traffic at all. So what I found that I had to do in trains, and I had to do in other environments when I'm using Pi, is that there's a Kafka plugin from Apache Metreon that works really, really well with Bro. And you can tie some of your Suricata traffic back to it as well. You can send that in the environment very lightweight over to a Kafka server, and then you can kind of munge that data any way that you want. The biggest problem that you're going to have, and I'm going to showcase this in a second, is though Splunk is easy, when you start tearing apart Bro network packet logs, this is heavy. We're not looking for a single indicator. We're going to tear down everything from the MAC all the way up to the authentication. So when you're capturing all that data and you're bringing it back in JSON so that you can make good decisions with it, that means it's very heavy, and you're going to blast a Splunk license pretty fast. So that's why we started looking at Kibana. We started looking at ways to drag Kafka back in, backhauling things over SSL and curl. And these things worked really well. Once you have it, you can viz this stuff out in more meaningful ways. These are, it should be, let me verify because I can't see on that screen very well, and I'm sure you can't either. But most of this thing, except for that bottom right-hand corner, is all bro logs. Now I'm extracting protocols. If I see a protocol that shouldn't be in my environment, say I'm an entirely Windows environment, I probably shouldn't see SSH. So very simply, by tearing down all these protocols, we can see those things happening. Again, carrying it further, just on network logs and using like JE3, we can tear down what software is in that environment as well, just off network traffic. We're not worried about pulling from the endpoints. We're not worried if someone remembered to put that brand new shiny server into our asset management and connect the agent to it. It doesn't matter. When we're working with Bro, we can see the traffic there. We can see the protocols that we're using. Additionally, when we're dealing with Bro, we have entity tables that get created. So you know what you've seen before, and you have good elements of what you haven't seen before. So it's a nice, effective way that when DevOps is shoving more machines in your environment and they're playing with live data instead of development data, that you're going to have the ability to pull that apart and see what's really going on in your network. I know you're not going to be able to see this. You know, this is like slide deck fail one after another here, but it's okay. What you can't see real well is that you can push those logs out and take everything from the size, the length of the flow, the size of the flow. So if you're looking for persistent connections, if I'm using Mimikatz or I've done persistence through Metasploit, I'm probably going to have a really long running flow here. So using Bro and using those things, you can start picking apart that information for free, and you can start looking at what's going on inside of it. Just make sure before you get started that you go ahead and allow, or basically you mute Hotmail, Outlook.com, Gmail. Those persist forever, and they're really going to skew the size of the data in the session that you're bringing across. But again, this is a highly modified, but not too terribly modified version of Kibana. So you can pull this down, use it at home, completely free. We've had to do some changes to ours to ingest the amount of data that we're bringing in. We were working with a huge social media vendor just a couple weeks ago. They may or may not have been in the news lately. But when you're ingesting many gigs of log data, some of the things that you're doing are going to have to change. So 10 gig links require some massaging, to say the least. So lessons learned. Pies are finicky. Some of the OSs that are released for them are finicky. Ubuntu was working really well for us when we first started this stuff with trains. Then they released a version that dropped Snap into it and everything fell apart. We did CentOS for a while, and that was working really well. And then there were some changes that came out with it, and then it fell apart. We had a lot of success with Raspbian. We were using older binaries of FileBeat for a while that were compiled and built for ARM and run on a Pi. The unfortunate thing is that they were abandoned, so now, once again, we're increasing the attack surface because we have known buggy transport software that you can attack right on the wire, and there's very little you can really do about that. So that's when we started using Splunk for a little while. Then we realized, man, this is going to kill us. We have to do something different. Again, the Apache Metreon Kafka plugin works really well in Raspbian and Bro. The patching is super simple. You can, with very few edits, you can include that into your CPU, into your landscape environments in Ubuntu, or you can manage it through Shuttle. But if you're doing about 500 or 600 of these Pi sensors at one time, you really want to have the ability to push those patches without the issue. Log verbosity, it requires some real consideration here. I kind of hit on this earlier, but I want to push this across. If you start playing in industrial controls, you start messing around in trains and airplanes, if you start occupying and taking up that whole line to get your logs back, you're going to cause some operational problems. And unfortunately, some of those are going to cause some accidents. So again, bottom line, don't DOS PTC. So where am I going from here? What am I going to release in the future for everyone to use? Sandboxing for file extraction. Bro will do FE live. You determine what MIME type you want. You can have it pull that off of the wire, drop it into a folder. Cuckoo can pick it up for those familiar with Cuckoo sandboxing. And you can blow that up and get the analytics. I finally have automated enrichment from Pastebin and Tor taking place right now, which has been really exciting. So what I mean by that is every 20 seconds, I've got an engine that's going and scrubbing all the most recent pastes that are coming down in real time and then gluing that data together with my logs in the enterprise. So instead of me waiting for a point-in-time Equifax triple dark web cafe latte scan, whatever the hell that means, I can go ahead and get that in about 20 or 30 seconds. Almost all the data, like he talked about in the last slide, is going to end up in a form or it's going to end up on Pastebin for sale. If you can get that information in 20 seconds and you can fire an alert off of it, it's going to save your hide. Waiting until something blows up to figure out if you can find those pastes is not going to be very helpful. More proto analyzers, make them verbose. I think I have 3 minutes left, so I'm going to rush through the rest of this. But the hard part is we have to do route determination. If you're operating in a train, we have to determine what route that the traffic's going to go so we can determine the verbosity that we can get from those logs without pushing something over. I've solved most of this, but this was not easy to solve because sometimes it's very hard to figure out what route something's going to go out once it passes the ACC or the REX. But still, it's very helpful to still be able to get some of those logs even if you're on a 220. Upgrading OT is hard. If you don't believe it, try upgrading 600 trains at one time. And then, so we want to make that easier, and then the other is finding a more efficient way of transferring from air-gapped networks. I want to thank some people in my last 60 seconds. My wife, she puts up with this trash. She brings me food and more dry erase boards. Fred Wilmot from Splunk, who's helped me out all the time. Chris Roberts, who hacked trains and planes with me. My team, Berkeley, for giving up all the webcasts and lectures that they didn't know they were actually doing until someone pointed it out. And then God, because I'm here. All right, do I have time for a question or am I done? Okay, any questions? Yes. I don't remember exactly the amount of time, but it was not very long. I was having to do it daily at the least, and on trains, we were still filling up. We're still filling up the SD card that was on a Pi. I'll be glad to give it to you. The integration is actually part of, and you can actually get it before I have a chance to get it online. It's built into Bro right now. So if you download the most recent source code, the Kafka plugin's already there for you. Have one more? Okay. Thank you very much. I appreciate your time.
Thank you very much. That's you.
Thank you.